You are welcome to Ojemike YouTube channel. You can as well follow us on Facebook on Ojemike Online Chemistry. Today, we will continue from where we stopped. We have already looked at this is Neco 2025 practical titration. We have done salt analysis. If you are viewing this channel for the first time, we have done salt analysis. How the analysis of salt, the different salt that we are asked in Neco. We have also done how to determine endpoint. We have done our endpoint and also the table for our endpoint. Now this in today's video, we want to look at how the parameter you will be asked to calculate in this titration. That is question number 1. We will be asked to calculate, and this one they give you this one to mix this one and this one. You use it for your what? For your titration. Then the next question you're going to see volume of carbon dioxide. All this one they might select 2 of it or 3 of it and give you, but for the sake of this knowing, we have to calculate everything here so that you will not be found wanting anytime you are asked to calculate these parameters. Now the first thing we are going to do, we are going to prepare our table. Now for you watching the first view for the first time, we have already looked at this preparing of table in our previous video. Just search for Ojemike YouTube channel, Ojemike TV. If you just type Ojemike TV, you will see it there. So we cut our this thing here. We are going to be using only this space for the. So we have be ready. Firstly, you have to check volume of prepared. Volume of prepared. The one you use, record it, 25 cm3. The one that you use, mostly this 25 cm3 is the one that is being used in your what? In your titration. Please and please do well to write this in that this table alone has 11 marks in Neco and YA, has 11 marks. This question alone is what? 2 marks. Okay. The next thing is be ready. We have to minimize our space. Bureau reading. We have first is also CMQ. It's not understood. So we have what? Volume of acid. We have volume of acid. So if you check Ojemike YouTube channel, this table have already been prepared under how to determine endpoint. Just Google how to determine endpoint in YouTube channel. You see the table there. So here, final reading. We have final as 27.00. Initial is 0.00. Final is 27.00. Here we have 0.00, 26.00, 26.00. 0.00, 26.00 and 26.00. That is how your table should look like in this food coming Neco. So the next thing you are going to do is volume, average volume of acid. Calculate average volume of A used. Average volume of A used is equals to, you have to look at one thing. This table alone, I told you, is 11 marks. Now you have to put when you are tabulating your burette reading, just know that all this one must be in 2 decimal place. On no account should you write maybe 25 point. You can, it is good for you to write what? 26.50, but not 51 or 52 or 53, because burette, the way it is now, it is not calibrated in such a way that you read that kind of reading. Is that understood? So must be in what? 0 point, that is point, either 0.40, 0.50, can be 0.60, 0.90. Do you get that? So don't write 0.92 or 93. It's not advisable. Second thing, you must always take your average volume of acid used, the concordance. Say repeat your experiment to obtain a concordant. Concordant means that value that are closely or value that are the range is together. Do you get that? Unlike this one, we have 27, 26, 26. you can take 26 and 26. 26 and 26 is what? So close. So that you have the average. So here we have 26.00 plus, okay, we have second plus third over what? Over 2. That is how to get your what? Your average volume of acid. So second title, average volume of, look at the volume of acid here. The average of it is what? You are not looking at this one up here, you are looking at volume of acid. Say average volume of what? Of E. You get that? Now what you do is that this one we have VA. Let me just shorten it. It's equals to second title is what? 26.00 plus 26.00 divided by what? Divided by 2. So our VA is equals to what? 26.00 cm. Almost endeavor to put this cm cube. Is that understood? Don't forget, put this what? Cm cube. So this is what you should prepare and keep. I don't know, for teachers, if you are a teacher teaching students, you should be able to prepare this kind of table, and of course they should get use of all these things before the day of the exam. Is that understood? So having done moles per dm, just remember concentration in moles per dm has two formulas. One of the formula is molar concentration is equals to mass concentration over molar mass. Second formula, CAVA over CBVB is equals to NA all over what? NB. These are the two formulas used in calculating concentration in moles per dm. In this case, you must substitute one in each of the concentration here must be in moles per dm. Now, if Neco decide to turn this question upside down, I want to teach you so that when they turn upside down, you should be able to tackle it. Now, you can only use this formula, this second formula, if one of the concentration is given in moles per dm in the question. As you can see here, A is this one is in grams per dm. B is what? Is in grams per cm, which we are going to convert it to grams per dm. Is that understood? So none of the concentration is given in moles per dm. If none of the concentration is given in moles per dm, you use this first formula. If none of the concentration, A is not given in moles per dm, B is not given in moles per dm, and you are asked to calculate any of the concentration in moles per dm, you use this one. Do you get that? You only use this formula. Listen, you only use this formula when one of the concentration is already given here. Are you following? You only use this formula, this second formula, if one of the concentration, like in this one now, we have A and B. If either A is given in moles per dm and you are asked to find B in moles per dm, you go straight and use this formula. But if A is not given in moles per dm, B is not given in moles per dm, you use this first formula. Is that understood? Those are the two formulas you can use to calculate mass molar concentration. That is concentration of A or B in moles per dm. Now in this case, now we are asked to use we should calculate this concentration in moles per dm and this one also in moles per dm. So we will use the first one, we use this formula to calculate this one, then we now use the second formula to calculate this one. That is all. Do you understand? That is all. Use the first formula, this first formula to calculate this one, second formula to calculate this one. If that one of the concentration is given in moles per dm here in the question, we would have used only this one. Is that understood? So let's begin with this one. Now, here, molar concentration. What is your mass concentration? Mass concentration is always expressed in grams per dm. Molar mass is what? What is your acid? And another thing, just note, don't come and use the molar mass of the equation here. Use the molar mass of the equation here in the equation. Do you get that? Use the molar mass of this one. Don't use this one. Is that understood? Beautiful. So now, what do? We say that molar concentration of what? Of A is equals to what's your mass concentration? I told you that we are looking at A. So mass concentration is expressed in grams per dm cube, not in grams per cm cube. If you are given in grams per cm cube, you need to change it, which you are going to see what we are going to do. So this one is got 6.4. Mass concentration is what? 6.4 over molar mass. What's your molar mass? You say but molar mass, but molar mass of HNO3 is equals to what? Hydrogen here is what? 1 plus nitrogen here is what? 14 plus oxygen here is what? 16 times what? 3, which will go, if you add the whole of this one, give you what? 63. So our molar mass is what? 63. So equals to, we have 6.4 divided by 63 equals to, we have 0.1102 moles per, let me write it this way. You have is equals to 0.102 moles per what? dm cube. The unit is very, very important. Do you get that? The unit is very, very important. So at the end we have what? 0.102 moles per what? dm cube, because you are asked to calculate concentration of A in moles per dm cube. Is that understood? Now we now proceed. We are done with the first one. We now proceed to the second one. The second one, we are going to use the formula method. We say this is our I, is our II. We say concentration of B in mole per dm cube. This is it. So we say that Ca, using formula, we have CAVA over what? CBVB is equals to NA all over what? NB. You are going to make what? CB the subject of formula. How do you do that? We say that CB will be equals to, if you remove this one here, you cross multiply. Do you get that? You cross multiply. This one will come here, this one, and this one that are 3 will be on top. So we now have CAVANB over what? Since you have removed this one, what is now left is what? VB and what? NA. So we have VB NA. Is that understood? So the next thing we are going to do is that CB is equals to what? What is your concentration of acid? Look at it here. I say that this formula you use, any of the concentration is always given in moles per dm cube. Don't come and use the concentration of gram per dm cube and put here. You know you will fail. So use this formula. You only use if Ca here must be in moles per dm cube. Cb here must be in what? Moles per dm cube. Don't come and use grams per dm cube and put here. Is that understood? So you have a Ca. We have what? 0.102 times volume of acid. What do you have? Our volume of acid, we remember, is that endpoint. That volume of acid, we have what? Va is equals to what? 26. Do you understand? So 26 times mole ratio. Your equation here, this is acid, this is what? Base. Are you following? Now acid, the mole ratio, what is in front of this acid? You have what? 2. So 2. What is in front of this base? There is nothing here, so it's what? 1. That is how to determine your mole ratio. Here in front of this one we have 2. Here in front of this one we don't have anything. It's only this compound, so is what? 1. That is how to determine what? Mole ratio. So the mole ratio of acid here, NB here, is what? Mole ratio of base is what? 1. You get that? Divided by volume of base. Volume of base is what? Volume of pipette. That one you put on top. We have what? 25 times. Oh, we know where we get this 25. I told you that when in that table on top of that, you see the volume of pipette. The one you use in sucking your base is 25. You must take the one you use. Look at the equation. Use what? either 20 or 25. So the one we use is what? 25. That is why I putting this put this value here. So the next one is what? Times what? Acid. Look at it there. 2. Mole ratio of acid is what? 2. Cb now will be equals to, let's divide 0.102 times 26 is equals to have 2.65 divided by what? 50. So at the end, our CB is equals CB now is equals to what? 0.053 moles per dm cube. Let me write it here. Okay, let me write CB is equals to 0.053 moles per what? dm cubed. That is what you have in your CB. Now we are done with this one and this one. So the third one is what? Concentration of what? Pure B. When you are calculating concentration in grams per dm cube, the one of pure B is what? In grams per dm cube. Use this formula. Molar concentration is equals to mass concentration over what? Molar mass. You get that? But you are going to use what? You are going to make mass concentration the subject of formula. Is that understood? So we say mass concentration is equals to what? Molar concentration times what? Molar mass. Do you get that? Now remember, your equation is what? The one that acid react with is what? Is 1. Remember, this one is an impure containing what? This one and this one. But when acid react with this one is just there. It's not because this one is a neutral salt. There is no way this acid will react with this one because this one is a neutral salt. Acid base titration means acid must react with what? Base, not acid reacting with a neutral salt. Do you get that? So you are going to use the mass molar mass of this one. Do you get that? So we now say, but molar mass of B is equals to what? You have Na2 molar mass of B. You have Na2CO3 is equals to what? Na is what? 23 times 2 plus 12 plus 16 times 3. At the end, have what? 106. Do you get that? So you proceed. Mass of pure base is equals to what? Molar concentration of pure base will have what? That molar concentration, the value was what? 0.2.6 divide 50. We have 0.052. So check that value. I've checked that value. So we have what? 0.052 times what? Times 106. You get that? Because you are looking for what? Mass concentration of pure. So at the end we have 5.51 grams per what? Per dm cube. This is your concentration of pure. Do you get that? Concentration of pure. The one you calculate is your concentration of what? Pure. Now let's go to the concentration. Now let's continue with this percentage of what? Purity. Anytime you are given percentage of purity, what you are going to see is that percentage of purity is equals to mass concentration of pure over mass concentration. Okay. Mass concentration of impure multiplied by what? 100. So that is what, how to calculate your what? Percentage of what? Purity. That is percentage of what? Purity. We have percentage of purity and percentage of what? Impurity. Do you get that? Now the mass concentration of pure you have already calculated to be what? 5.5. Is that understood? Then the mass concentration of impure is the one that you have here. Look at it here. 8.0 grams per what? Cm cubed. But mass concentration is always expressed in what? In dm cubed, not in cm cubed. So we need to change this one. So we say, but mass concentration of impure is equals to 8 divided by 500. That is, you have to change it to what? To dm cubed times what? Times 1000. So what you have is what? What you have is 8 divides 500 times 1000 is equals to what? 16. So equals to what? 16. So put it in your formula. We have percentage of purity is equals to mass concentration is what? Of pure is what? Is this one. Mass concentration of pure acid is the one that you calculate, while the one of impure is the one that is given in the question. This is the one given in the question is impure, while the one that you calculate to get is a what? Of pure. Is that understood? So we have what? 5.5 divided by what? 16 times what? 100. You get that? And using the formula. So we have 5.5 divided by 16 times 100 is equals to, we have equals to 34.4%. That is a percentage of what? Purity. Percentage of what? Purity. Then percentage of impurity what? Percentage of impurity is equals to percentage purity. 100 minus percentage purity. So therefore 100 minus what's the percentage of purity is what? 34.4. So therefore 5.6%. So percentage of purity is what? 65.6%. Now we are done with this one. Let us go to this one now. Volume of carbon dioxide at STP. Volume of, you say that volume of CO2 at what? At STP. Remember, any gas at STP is equals to what? Is 22.4. STP simply means standard temperature and what? Pressure. Is that understood? So what you are going to do is that, remember, what yield this carbon dioxide is this sodium thiazocarbonate, and how many moles of this sodium thiazocarbonate are here? Is just 1. How many moles of carbon dioxide are here? Is what? 1. Mole is that what is in front of carbon dioxide. If 2 is in front of carbon dioxide, it would have been what? 2 moles of what? Carbon dioxide. Like in the case of this one, they ask how many moles of this thiazonitrate is what? 2, because of what? 2 is in front of what? This one. But here nothing is here, so it's what? 1, and nothing is here is what? 1. Well, let's say 1 mole of Na2CO3 will give you what? 1 mole of what? Of CO2. And you say that 1 mole of Na2CO3 will give you what? Will give you 22.4 moles of what? CO2, because of what? Carbon dioxide. I told you that STP is what? Standard temperature and what? Pressure. Now how many moles of this one? 0.0. The mole of this one is the molar concentration. The value you have for your molar concentration. When you are, that is your CB. Your CB, what's the value of your CB? We have what? 0.52 mole of NaCO2 will give you what? 22.4. Do you get that? Therefore 0.052 times what? 22.4. So we have what? Our answer is what? 1.165 dm cubed. So this is the volume of what? Carbon dioxide at what? At STP. Is that understood? So we now go to the last one. Mass of sodium ion in what? In 1 dm cubed. Mass of sodium ion in what? 1 dm cubed. So this is our C's. We say that mass of sodium ion in what? In 1 dm cubed. What you are going to use anytime you are asked to calculate mass, you see moles times what? Times molar mass. Molar mass. And we know that molar mass of sodium is equals to what? 23. Do you get that? Molar mass of sodium is what? 23, because we are looking for sodium. Do you get that? So now what is the moles of what? This what yield this sodium is this thing. Sodium is coming from this one. So the mole of this is what? We are looking at the molar concentration. Look at it here. Do you get that? So we say that mole is what? 0.052 times what? Times 23. So at the end we have 0.052 times 23 is equals to what? We have 1.196 of what? Look at here, mass of this in 1 dm. So we have at the end we have 1.2 in 1 dm cubed. That is the mass of sodium in 1 dm cubed. Please and please, for more of this video, subscribe to my YouTube channel. This is Ojemike TV. You can as well follow us on Facebook on Ojemike Online Chemistry. Do well to like, share, and comment. Please and please, as you view, encouraged by what? Subscribing. I love you so much. Bye bye.